brackets around x plus 3, and they'll say, well, there's brackets. So we go 3 to the, there's not brackets, you put brackets. So that does not count when you put it. If it's not typed, you put the bracket there. So that's not what it was intended to be. So what you can write it as is sine x plus 0 plus 3 if you'd like. Then that would force you to say, hey, it's not a horizontal translation, it's vertical. So it'd be a vertical translation, 3 up. This is also your midline or your median line. You know how I said midline or median line up, that line that cuts the graph horizontally in half, right? Or midline down. Your D value is actually the equation of your midline. So if we wanted to, we could say midline or median value is going to be at y equals 3. So at y equals 3 is going to be my midline. From that line up is my amplitude, down is my amplitude, right? So change when my graph is down. So my graph is the normal distance this way, which would be my amplitude, right? Now I just take it and I move it 3 up. Did my amplitude change? No, my amplitude's still the same distance. It literally just moved itself up. So it didn't change. Now, how do I get the range? What did I tell you last day? If you take your median line, which we now know is our D value, which I told you yesterday, it said you didn't know what it was, and I add to it my amplitude. So I take my D line and I add to it my amplitude, I'll get my maximum, right? If I take my D line or my median value and I subtract from it, I get my minimum. So range is actually quite easy to find. It's going to be D plus the absolute value of A, D amplitude, right? It's the distance. So your D is 3. What's your amplitude? What's your amplitude? -2. So what's my range? D plus the absolute value of A, D minus the absolute value of A. So my maximum is going to be -2 plus 1, which is -1. And then it's going to be -2 minus 1, which is -3. -1, -3 like this. Is that what I do? become so it's going to be 2 plus 3, which is 5. Post graph. Or what my x is, let's pretend one of our normal x-intercept would be when y is 0, right? When y is 0. So we think about it, we're going to have, say our x-intercept was at 2, 0, let's say. It's going to be at 2. I plug in 0, but I add 2 to it. So now it's going to be at 2, 2. It is changing, right? The only time your x-intercept doesn't change is if you only have a vertical stretch. If you have a vertical translation, it's going to shift that whole point up. So your x-intercepts do change. Do your y-intercepts change? So let's pretend normally our sine graph normally has a y-intercept at 0, 0, right? If I plug 0, 0 into here, what happens? 0, comma, 3 times 0 plus 2, 0 and 2. Did it change? Yeah, it took my y-intercept at 0, 0 and it moved it up 2. So yeah, my y-intercept changes too. So remember, if it's asking you if something changed, you can always put the original y equals sine x into your calculator and compare it to the new one as well, right? Try number 4 and 5. So for the coast graphs, it's not that these aren't applicable to the coast graphs. It's just that at this point, I don't want to overwhelm you with the coast, but we will as we go along. So for this one, we have a vertical stretch by a factor of 2 about the x-axis. Vertical translation 3 down. What's the range? D minus the absolute value of A, which is -5. D plus the absolute value of A, Then cos, what's your x-axis in? Remember I told you the only way you're going to know your x-axis is if I give you a c value. X minus something or x plus something. That's the only way you're going to know, because this is what? Radians. So what's your x-axis in? Radians. If it was in degrees, this would be x minus 90 degrees, because 90 degrees is pi over 2, right? So if it was in degrees, this would be x minus 90. So all we have here is a horizontal translation, pi over 2 to the right. Same rule goes here. So what do they do on trig? They'll give you your b, x plus c all together, and you have to remember to take that b out. Because the only rule for transformations, horizontal transformations, is it needs to be 1x plus something or 1x minus something, right? So if you have a b value in front, you have to remember to take that out. Remember how I told you that's going to be the big catch? That's what they're going to do throughout. They'll do it in logs. They'll do it in exponents all. They're just testing to see if you remember to take that b out. If you forget to take it out, your b value will still be the right b value, so your horizontal stretch will be correct, but your translation will be wrong every single time. So sometimes they take the b value out for you, and sometimes they don't, and you have to remember to take it out. Okay. So this is a cos graph, and we can compare the amplitude, range, period, domain. Did my amplitude change at all? My normal cos amplitude, the normal graph we're looking at here, if we're wanting to know what the transformation change is cos x. It was at 1, it's still at 1. My amplitude didn't change. My range is d plus a, d minus a. My cos range is normally -1 to 1, just like sine is, right? Because literally cos and sine are just a little bit of a shift, a pi over 2 shift from each other. Remember, we went over that? So the range is still all of my x values are being shifted pi over 2 to the right. So it's going to be, my normal point would be xy. My new coordinate using mapping is going to be x plus pi over 2 and y. My x-intercept is at 2 and something. It's shifting pi over 2. Yeah? I just put not applicable so that we could get through the questions faster. But no, you could totally be asked all the same things. Yeah. No, it's not that it's not applicable. It's just that I want to not take 7 years to do the example. Yeah. So x-intercepts, these change because we're moving pi over 2 to the right. And your y-intercept, think about that. Your y-intercept. Your y-intercept for cos is normally at what? If it hasn't been changed on the original one. For sine, it's 0, 0. For cos, it's 0 and whatever cos is. So 1, right? It's 0 and 1. Well, if I plug 0 and 1 in here, I'd get pi over 2 and 1, right? So my y-intercept will change. Because the point at pi over 2 to the left is now going to become my y-intercept. Okay, we're going to flip to the conclusion on the next page. Actually, sorry, before we flip to the conclusion, what is this in? What's my x-axis going to be in? Degrees. This one's going to be in degrees. What's my x-axis going to be in? Radians. Here they took my b value out even, so that was nice of them. Here they took my b value out as well. The trick would be that they don't take it out, and you have to remember to take it out, right? Okay. In general, y equals a sine b theta plus c. Do you see they took the b out? They took the b out, right? A represents the vertical stretch. 2 pi over b or 360 over b, 360 degrees over b, depending on what your c value is. If your c value is in radians, you're going to use 2 pi over b to find the period. If your c value is in degrees, you're going to use 360 over b. Okay? The c represents the what? Like the d value is, and it's going to be a horizontal line, and it's the horizontal line that cuts the graph in half horizontally, right? So same amount up to get to my max is the same amount down to get to my min. So your amplitude should work. And the range can be found by doing this. This is the best way to write it, I guess. You can go y such that d minus the absolute value of a, because that's going to give me my min, is less than or equal to y is less than or equal to d plus the absolute value of a. YR. Or d minus the absolute value of a, comma, d plus in interval notation. When you're done that, flip over. This is where it gets fun. Super fun. Okay. If you pay attention, if you pay attention, the phase shift is not hard to find. There's easy ways for us to figure it out. So, given the equations for each of the following graphs in terms of both, give the equation, sorry, for each of the following graphs in terms of both sine and cosine once they have undergone a minimum possible horizontal shift. That's the reason why we say that is normally on a cosine graph, your maximum is on the y-axis, right? Well, you have a whole bunch of maximums along the way, right? So you could technically say that your graph translated to this maximum, the second one to the left, if you wanted to. But then your answer would be totally different than the diploma, right? Because they're probably going to use the minimum one. So that's why they'll still say it's the minimum shift. So you have to look. Right? Now, I can ask you to find sine or cos of any graph, because remember, sine and cos are literally just a pi over 2 shift of each other. Then if I shifted them pi over 2 one way, one or the other, I would get the graph completely on top of each other. For the cosine graph, we need to identify the x-coordinate of the maximum near the origin. Cosine. So if I want to find my horizontal shift when cos is positive, so when it's a positive cos x, when I want to find my horizontal shift, I just figure out, hey, before it was shifted, it was on the y-axis, right? It's no longer on the y-axis, my maximum, so it must have horizontally shifted. If my maximum is still on the y-axis, then no horizontal shift occurred. Okay? So we just figure out the closest x-coordinate. Tell you that your a value is negative. So if I looked at the original graph with my a value being negative cos x, what's on the y-axis now? Graph, and I want to figure out the horizontal shift, I'm going to actually look for the closest minimum to the y-axis, see how much it moved. Okay? Because if it's a positive cos graph, we look longer on the y-axis. So I go up here and I find out, okay, it moved whatever this value is here to the right. That's all it did. come up with 4 different cos and sine graphs. Yay, I know, super fun. I can go y equals, my a value is 1, but that's not my a value. That's actually my a value could be 1 or negative 1. So I could literally have 4 different graphs. I can have negative 1, positive 1, pi over 2. Why plus pi over 2? Because I actually moved pi over 2 to the left, because you always started normally at the y-axis, so it's completely depends on what the style of question is.